Today we are going to be creating circuits physically using a breadboard and the components that we used in the previous lesson that we designed in Tinkercad. So I'm going to do my very best in order to show you where things need to be plugged in and explain why that's important. I know that this is going to be very small, especially if you're watching on your iPad, so I will do my very best to explain it. Ultimately, if you have trouble, ask your neighbor, your partner. If they can't give you help, then I am happy to help you as well. So we have our breadboard here, and as we learned yesterday, we had power plugged in with 3 volts from yesterday plugged into the red rail here. And in this case, the negative is blue. I really wish that it was black because black is the standard for the ground or the negative. That's very, very common in circuitry. So I'm a little, I guess, annoyed that this is not black. So we have red and we have blue. Now remember that these ports right here, these rails, when you plug something into it, it gives that same connection to everything that goes down here vertically. Anything that is plugged in here will power the rest of the rail on that side going to here. So in this case, there's 1, 2, 3, 4, 5 different pins that connects to. So how we are going to use this, we are indeed going to be using a microbit. And yesterday you had the ability to, let me make sure I'm in the camera here, you had the ability to take your jumper wire and go from the 3 volt into the positive, and we put this one over here, and then we also grabbed the ground and that went into the negative in here. So we can't connect this directly to here. There are some alligator clips and some ways we can do that, but I have an easier way for you. I'm going to be a little bit different, but you'll get the idea. So we have this right here, which is called either a dragon tail or a T extension, or in this case it's called a GPIO board. Okay, so it has multiple names. But let me set this down here since my hands are shaking a little bit. So what this will do, if I can get it stood up, is this essentially makes your microbit connection onto the breadboard. So let me show you how that works. If I were to plug this in, so you want to face it so that the buttons are facing the front of the tail here, and you push it in, not super hard, but it should slide in and snap in. Okay, you can see part of the circles down here. And then what we need to do with these bottom pins here is we need to connect this to the breadboard. Now, where we need to put it is not super important in most cases, but today we want to have a lot of workspace. So what I want to do is this top pin right here, I want to have that plug into the top pin right here. Okay, so I'm going to plug that in, and I want to make sure that I am splitting the middle. Hopefully you guys can see that. Splitting the middle, and I'm going to push these pins in. Okay. A super important thing to note. When students take out the dragon tail, when you take this out or when you push it in straight down. When you pull it up, you can just kind of wiggle it and pull it up like this. Do not, please, I've had to bend a lot of pins back and even had some broken because students take them off. It's not plugged in, but let's pretend it's plugged in. They peel it off like this, and then that bends the pins. So that's not very helpful. So we're going to plug this in just like this. Okay? All right. The other thing that we have is we have a USB cord. Now, in the future, we're going to use this USB cord to code stuff on a website called MakeCode. That's going to be on your computer, and we can actually send the code to here to interact with other components. Similar to how we use the Hummingbird, if you remember using the Hummingbird. I'm going to plug this in, and let me plug it in the correct way. Okay, in this case, the code that was on it before still exists, and you don't need to necessarily worry about that because we're not going to be actually running code on this, but just for your knowledge, how this works is, oh, that plug's going to be in the way. Let's try that. How this is going to work is the Anytime you send a new code to the microbit, it'll automatically update and wipe out the previous one. So if you can see on here, or it might be harder to see on here, you might just have to look where I'm pointing and look at your board here. We have some pins down here. So in this case, the very bottom left one, not these connectors here, or bottom right one, I'm sorry, is 3.3 if you're looking at it from here. 3.3. Okay? In fact, let me do this. There's another way. Let me plug this into the side. This will be easier for you to see also. So we can give power to the side. Okay. Same thing. Okay. There we go. That's better to see. So we have a 3.3 that's plugged in. You see this right here. And as we go across, it's powering that rail. We also have a 3.3 at the very top, and we have a couple GNDs, the grounds. So in order to start, okay, we have 5 volts on this side. We're not going to use 5 volts. 3.3 is going to be a little bit safer on the LEDs, specifically since we're using LEDs. Even though we're using resistors, we don't want to send too much power through those. So let's try to wire up at least a couple of these circuits here. So we have a jumper wire, and the jumper wire colors don't matter. So whatever colors you pick is fine. I'm just going to try to make it more helpful for you by using the colors. I don't actually have a red. I have an orange. So let's pretend this orange might not look great like orange, and this black. So what I need to do, like we did yesterday, is I'm going to plug. So this one right here, under my finger, this one says GND. Might be hard to see, but look at your board. Okay, and I want to plug it in right next to it. It's going to be really, really important to look straight down on the board when you plug it in, because if you're looking at it at an angle, very, very often you'll either be one up or one below. So that is GND, and what I'm going to do now is I'm going to plug the other side of the jumper wire into the ground or the negative. So now I have a negative or a ground down this whole rail. I'm going to take my 3.3, and just to keep this out of the way, I'm going to plug it in at the bottom down here, but I'm plugging it into the positive side. Okay, so I guess I can plug that in here too. That works. So I have, let me see if I can get this out of the way in the video. There you go. So this bottom one here is 3.3 across. I have that jumpered to the red. Now yesterday we had both of them at the top, but it doesn't really matter where you plug it in. You can plug it anywhere on this rail here, and it'll give that power to these other ones here. Okay, so where this is going to get a little bit messy, now that I've done that and showed you, in fact, I'm going to move it back up to the top. Just so, let's see if it's out of the way. Ugh, it's not great, but we have a little bit of workspace down here to play around with, or even on this side. We can jumper wires across. That's fine too. I have my LED, and we learned yesterday that, let me see if I can set this down so you can see it a little better. Probably not great. I don't think it's going to focus on my hand. But we have our LED. Oh, that's not too bad. We have a shorter leg and a longer leg. The longer leg is called the anode, and that is your positive side of the LED. So LED means light emitting diode. Diodes are components that electricity can only flow in one direction. So if we put this LED in backwards, in fact, it will not work. So yesterday on Tinkercad circuits, the longer leg was the one that looked bent. Okay, that's going to be your positive. So here's what I want to do. I'm going to lay it down sort of so you can see, and then I'll plug it in. So in this case, when I plug this in from this perspective, the one that's closer to the board is my longer leg. So that's going to be taking the positive feed. So I'm going to plug that in 2 parts. In my case, I am in rows. The positive leg, the anode, is in row 21. And the cathode, which is the negative, is in 22. And I just simply put it right here in the middle. You can put it on either side of this rail. What I'm going to do now is I'm going to take another jumper wire. You can use any color. Color does not matter. And I know that this rail here has a positive. So I'm going to take, let's go close to it. I'm trying to keep my wires out of the way from the camera though. Okay, so I have that one plugged into my positive rail, and I'm going to plug it in next to, so in this case it's going to be row 21. I'm going to plug it in the same row as the long leg of the LED. We also learned yesterday that it's good practice to put a resistor in line with an LED depending on how much voltage there is. Now, these LEDs that I'm using here, this red one, in fact, is rated at between 2 volts and 2.2 volts. So if we did send power through it directly, it would probably work. However, over time, it would damage it. It would especially damage it if we came off of the 5-volt pins over here. What I want to do now, similar to what we did yesterday. Now, remember, this is a resistor, and the resistor resists the current, so it slows it down. So the purpose of the resistor, let me set this down. This is a 220 ohm resistor. That's just what should be used in this circuit. But the purpose of the resistor is to slow down the current so that it does not damage the LED in this case. So we have the positive coming into the positive side of the LED, the anode. It does not matter which side of the circuit you put the resistor in, because electricity through a resistor can actually flow in both directions. So that does not matter. But I'm going to plug one leg of this LED into the same row. In this case, it's row 22. It's right below that jumper wire. Hard to see in the video, but we're going to plug it into the same row as the shorter leg. And then I'm just going to pick another, I'm going to bend it, you can bend it, and stick it into another port. I'm going to go in row 26. You don't have to go on 26. You can go anywhere around there, but I'm going to make mine look like that. Okay. So once again, I know, Mr. Hale, you don't need to tell us again. We have power going out of the 3.3, down that rail, through the positive side of the LED, through the resistor. Now, we learned yesterday also, in order to complete a circuit, that we need to have it connect to the other side of the power source. This is not giving it any full power because we need to complete the circuit. Right now it's open because the negative side of the LED isn't going back to the negative rail. So let's do exactly that. Anywhere on this negative rail, plug in your negative. I have a black wire. And then I'm also going to plug that into the same row as my LED. And would you look at that? Oh my goodness. How fantastic. Okay, so now that we've done that, similar to what we did yesterday, we're gonna wire up a couple other ones. And now this one's lit, okay? We're gonna jump over here and we're going to make a very similar circuit to what we have here. But what I also want to do in that circuit is we're going to add this tiny little guy here. Let's see if you can see it. Let me flip it over. That tiny little guy is a push button. And in the simulation that you saw in the last lesson, in fact, it had 4 pins on it, which made it a little confusing because we had to rotate it. This one only has 2 pins, so this will be a little bit easier for us to make sure it's in the proper position. We have a couple options here. We can either jumper from one of these rows over here where we have the 3.3 in the ground. We can jumper across there. We can do that. Or we can, in fact, just jumper across the actual rails. So watch this. Color doesn't matter, but just for your sake, I'm going to keep this consistent just so we can see. I have a black wire. I can either pull right off of the ground, off the microbit, or I'll stick it in this bottom row here on the negative side. And I'm going to plug it over here. So now what we've done is we've connected the ground that's coming down this side also to this side. So we have a negative feed there. Let me grab a orange one, which we'll pretend is red. I'm going to plug that into the bottom positive, and I'm going to jumper that over to this side. Okay, so we have our negative and we have our positive. So that rail now is powered. Let's replicate. I'll try my best to do it in this space here since you can see that a little bit better in the video. Let me slide this over. And we're going to put the button in. So first, let's just wire up the LED, the exact same way. And then we'll move things around to put the button in. That makes more sense to me. All right, let's see here. You know what? I need 3 seconds because I need to grab another LED. Give me 1 second here. 3 seconds. Okay, more than 3 seconds. That was a lie. I have an LED kit here. Let's see if I can back this up so you can see it. But it has a whole bunch of different colors in it. So we have some red, yellow, blue, white. It doesn't necessarily matter which ones you use, but I'm going to pull a yellow one right now. So we're going to use a red and we're going to use a yellow one. Same deal. We have a anode and we have a cathode. We have a positive and we have a negative. I'm going to, let's put it as close to this one, same rows. Looks like on the red one, the longer leg, the anode is in row 21. And the cathode, the negative, is in 22. So let's do the same thing. I'm going to put it towards the middle here. And let's grab another resistor. So we have a resistor here. Wonderful. I'm going to jumper this in row 21 again. I'm going to cheat. Watch this. Rather than jumpering it down, so over here, we jumpered this down to row 26 and then jumpered row 26 over to here. I'm just going to, basically, you don't even need this. I can take this resistor and I can plug it right into that rail. That's the exact same thing. I mean, if anything, it's eliminating variables. Oop, I'm pushing stuff on my microbit. There we go. Check that out. So we essentially just eliminated this. Okay, and let's grab another red one. And I'm going to go from the red rail. Let's see what's out of the way in the video. That's out of the way. And I'm going to power this to, bingo, row 21. So now we have 2 of them. Let's now go ahead and let's take our button. Let's add it into our circuit. So this button, much like the resistor, it doesn't matter what side, whether it's the positive or whether it's the negative. However, what we do need to do is we need to move something to make space for this. So let me explain this. In this case, follow me on this. I'm going to unplug the positive side. So that LED goes out. Let's just put it over here for a second. And now I have my button. So you can hopefully see, it might be small on the iPad, you can look at your button, you can see that there are 2 pins on it. I want one of those pins to go in the same row as the LED, and then I want the other one, it'll go up 2 pins in fact, so it'll be 21 and 19 in this case. So if I plug it into 21 and 19, okay, great. There. So what you can't see is that the pin that's under this side is now connected essentially to the anode. And the pin that is in row 19 that you can't see is not connected to anything right now. And that's where we're going to plug in our positive. So let's plug that into port 19. I made this a little tight here, but that's okay. And so now, when I push this button here, we now have power. Bingo. Okay, so for today, you're going to submit 2 exit tickets. This is your first one. If you could do me a favor, please, and use your iPad, pause the video, take a picture of this circuit, and then what we're going to do is we're not going to fully take it apart, but we're going to build a couple other things within this. We're just going to swap out some pieces. So the first one just has a regular LED always on, right? Because we don't have a switch or anything in it. And that works. Okay? So hopefully you've taken a picture. And if you've done that, we're going to swap in a couple other things now. So we have a button here, and we have nothing here. Let's see here. What's the easiest way to do this? All right, let's grab, let's let's grab this guy. This might be harder to see with just because of my lighting. So this thing right here is your photoresistor. Photo meaning light. So what I'm going to do is I'm going to pop out my button. There we go. And I'm going to put these. This does not matter on the direction either, just like the button. I'm going to put these in the same holes as the previous one. So this is 19 and 21. 19 and 21. Okay. Oh, it does work. Great. So how this photoresistor works is some sort of sorcery in the first place. I'm just kidding. It's science. But the purpose of this is it's basically a resistor that will change depending on how much light it has. So if I were to cover, let's watch this LED here. If I were to cover this, do you see how that goes out? And now it's back on. Out and on. Not fully out. But this is essentially a variable resistor. Similar to this guy. This is called a potentiometer. Okay, so let's give this one a shot too. So we have our photoresistor. You don't need to take a screenshot or a picture of this one. We're going to skip this one. And now I have a potentiometer. So for us to be able to use this, I'm going to put it in on this way. Let's see here. It's going to be in row 21. Let me lay it so you can see. And the middle pin in this case is going to be in 19, which is the same as the positive feed. But if I were to plug this in here, let me push it down. This is a knob, like a dimmer switch that you have in your house. Look at that getting brighter. Whoa! So if you think of a dimmer switch that you have, or like a volume knob on a stereo, that's a potentiometer. And so what this is it's a variable resistor that you can set and you can leave. This is also a variable resistor, but that resistor functions based on how much light's coming through it. This is pretty cool. I'm a nerd, and that's okay. I think this stuff's neat. So we have the potentiometer. Let's do one more thing. How can I do this? All right. Let's take out, I have this little guy here. This is called a piezo or a buzzer. It's not necessarily a speaker. I'll explain how this works here shortly. But let's pull, how do I do this? Let's pull our positive wire out that's feeding the LED, the ground wire out that's feeding the LED. Let's actually pull out the LED and the resistor. So let's leave it like this. If you need to pause this for a second to make sure you're doing this properly. We have our 3.3 still plugged in, and we have our ground plugged in. But then we have these wires that we're going to end up powering this buzzer. But let's put this button back in here. I'm going to put it in my case, I'll put it in row, I don't love it there. It's kind of in the way of my dragon tail. Let me pop this back up. Not a good place. Okay, let's put this down even just like one or two more. And there. Okay, so in this case, it looks like I am in row 19. I'm going to plug my red, it's orange, but pretend it's red, my positive into row 19. So just like on the other side, there's a pin under, you can't see it. There's a pin under this one that's in the same row here. All right? Then, if you look at your buzzer, there is a plus sign on it. I don't know if you can see that in the video. There's a long leg on it. There's an anode. Okay, so the longer leg on this needs to be plugged into the other side, the other row where the button's coming out. In this case, it's 21. I'm going to push that in. Let me get some space. Oh, there it is. So now we're in row 21. It is hard to see because, in fact, it's underneath it. And I believe that this one is in row 24, the negative. If you look at the top of your button, you can also see, or your buzzer, I'm sorry, you can also see a positive symbol to show that that's power to the positive side. So if I were to push this button now, I don't suspect that's going to get annoying. Just so you know, something cool that you can also do, we're not going to do it in today's video, but I can put a potentiometer in the same circuit as this, essentially, so that when I turn the potentiometer up and down, it will make this thing buzz louder or quieter. Okay, so we got a button here. And how this buzzer works, in fact, is creating electricity. There's two thin metal discs that they vibrate so fast that it creates that squeaking or that chirping sound. So that's a rather interesting technology that's used for that. So this is going to be the other part of your exit ticket. Take a picture that I can see the wiring on this, not from the angle that you're looking at it from the bottom, but take another picture here, and today you're going to upload 2 photos. The first one, which I already showed you, and then this one's going to be the second one. Okay, I'll know that you're done when I hear this. That's great. Also going to be a little bit annoying, so let's kind of keep that under control, I'm hoping. But once you've completed these steps, submit your exit ticket, and now we have a little more familiarity with how to wire up a breadboard using the power source of a microbit.